how do we differentiate a set of two questions like this? Let's see how to differentiate this kind of question. The first one says if y equal to sine to the power of 5 in a bracket tan and a bracket cos x cube, and then this way. Okay, so the y, the x equal to differentiating with respect to x of sine tan bracket cos x cube all to the power of 5. This sine to the power of 5, the 5 is actually affecting all the content of the bracket. So this is the best way to interpret this. So in this case, chain rule can be applied. So in this case, our n, which is the power, equal to 5, and our u now equal to sine tan and the bracket cos x cube. This way, that's our u. And then differentiating u is going to be, we're going to differentiate all the three functions that we have one after the other. And then when you differentiate sine, you get cos. Okay, so write this in bracket tan and then bracket cos x cube. And then when you differentiate tan, you're getting sec square. Okay, so you multiply sec square in the bracket cos x cube. And then on a bigger bracket now, when you differentiate cos, the next thing is to differentiate cos x cube. And that's going to give us in the bracket negative sine x cube multiplied by 3x squared. You know, this one, you need to use another chain rule to sort that out. So it has to be this, okay, differentiating cos x cube. It has to be negative sine x cube multiplied by the differential value of x cube, which is 3x squared. Okay, then our chain rule can be applied. And the chain rule says n bracket u raised to the power n minus 1 times the differential value of u. And therefore, in this case, what we do have is n is 5. So it has to be 5 in a bracket. The u itself has to be sine in a bracket tan in the bracket cos x cube raised to the power of 5 minus 1. Then multiply by everything we got for u prime. And then u prime is cos in the bracket tan in the bracket cos x cube this way. And then bracket sec square cos x cube this way. And then multiplied by negative sine x cube times 3x squared. Okay, and then we can actually press further to write it out this way. Okay, we actually have 3x squared here, and then we actually have 5. So this and this can be used to multiply each other, and then we get 15x squared in the bigger bracket. This is sine bracket tan bracket cos x cube this way raised to the power of 4. Don't forget 5 minus 1. Okay, times everything we ever have here. So that becomes in a bracket cos. Okay, cos. Okay, smaller bracket tan and then bracket cos x cube. We close our bracket this way, and then we still have other bracket sec square bracket cos x cube in the bigger bracket, then multiply by negative sine x cube. And that is the answer to such question. And then let's go for the other question. The other question is y equal to cos to the power of 7 sine sec x squared. So we're still going to follow using the same kind of pattern to get this question to solved. So let's go for the second question. The second question is y equal to cos raised to the power of 7 bracket sine and then bracket sec x raised to the power of 2. Okay, in the bigger bracket, just like we wrote the other time. Differentiating y with respect to x will be differentiating with respect to x everything we have there. The 7 can be written outside to affect all the content of the bracket. So we have cos, okay, in the bracket sine in the bracket sec x squared raised to the power of 7. And then, therefore, we go ahead to have our n, the power, equal to 7, and then our u equal to everything we have here. And that is cos, bracket sine, bracket sec, x squared. Okay, that is our u. And then, of course, differentiating u is going to be differentiating cos is a negative sign. So we are going to have negative sine in a bracket sine in a bracket sec x squared, sec x squared in a bracket this way. And then we go ahead to differentiate cos. We'll be taking one after the other. So differentiating sine is actually cos. So we're left with sec x squared. Okay. And then differentiating sec x squared. It has to be a bracket of the differential value of sec x squared is sec x squared times x squared multiplied by the differential value of x squared itself. That's 2x this way. And then subsequently we can apply our chain rule. Now the chain rule says it has to be n on the bracket u raised to the power n minus 1 multiplied by the differential value of u. And then in this case we have 7. That's a power there in the bracket. The u here is cos in the bracket sine in the bracket sec x squared raised to the power of 7 minus 1, and then multiply by the u itself. Okay, I mean the u prime, which is the differential value of u, and then we have it here. That's going to be negative sine in the bracket sine in the bracket sec x squared in the bigger bracket, and then multiplied by cos in the bracket sec x squared, and then multiplied by sec x squared multiplied by sec x squared times x squared multiplied by 2x. So in the bracket sec x squared times x squared and then multiply by 2x. And therefore, since we have 2x and 7 here, that can be used to multiply each other. And that's going to be 7 times 2x. We have 14x in a bracket, cos bracket sine bracket sec x squared raised to the power of 6, that's 7 minus 1, and then in the bracket negative sine in the bracket sine in the bracket sec x squared, and then multiply by cos, okay, bracket sec x squared, and then in the bracket sec x squared times x squared. So that is the answer to such question. Thank you. Kindly subscribe to my YouTube channel.